sklearnexceptionsNotFittedError. Description: the not fitted error exception is raised when you attempt to use a scikit-learn estimator such as a classifier, regressor, or transformer before it has been fitted to the training data. In simpler terms, you are trying to make predictions or apply transformations using an estimator that hasn't learned any patterns from the data yet. Inputs: training data. This is the data used to train the estimator. It typically contains both input features and corresponding target values for supervised learning. Estimator: the scikit-learn model you want to train, such as logistic regression, decision tree classifier, or standard scalar. Outputs: fitted estimator. After training, the estimator learns the underlying patterns from the data and becomes ready for making predictions or transformations. Predictions or transformations. Once fitted, you can use the estimator to make predictions on unseen data or apply transformations to existing data. Steps: training fitting. This is the process of feeding the training data to the estimator to learn patterns, prediction or transformation. After training, you can use the fitted estimator to make predictions on new data or apply transformations to existing data. Metrics: accuracy classification, a measure of the model's ability to correctly predict class labels. Mean squared error regression, a measure of the average squared difference between the model's predictions and the actual target values. Visualization plots: decision boundary classification, a visualization that shows the regions in feature space where the model predicts different classes. Residual plots: regression plots that show the difference between the model's predictions and the actual target values. Fine-tune parameters: regularization parameters controls the complexity of the model to prevent overfitting, e.g. see in logistic regression. Tree depth or splitting criteria: decision trees determines the complexity and depth of the tree, impacting the model's ability to fit complex patterns. Uncertainty methods: confidence intervals regression quantify the uncertainty associated with the model's predictions. Probability estimates classification provide probabilities for each class label, indicating the model's confidence in its predictions. Challenges and fixes: challenge 1, attempting to predict or transform before fitting. Sample use case: trying to use model predict xtest without first calling model fit xtrain. Y train. Fixes: make sure to call model fit xtrain. Y train before attempting to use the model for prediction or transformation. Challenge 2, forgetting to fit a model after modifying its parameters. Sample use case: changing the regularization parameter in logistic regression but forgetting to refit the model. Fixes: ensure that you refit the model after any parameter changes using model fit xtrain. Y train to retrain the model with the new parameters.